So in the last video, we discussed kind of a longer way of finding the sum of an infinite series. And there's nothing wrong with doing it that way. It just takes a long time. And sometimes it's harder to see, especially if it converges, because remember I said if it converges, you have to tell what number it's getting close to. And so with those types of problems, sometimes it's really, really difficult to figure out by doing it that way what number it gets close to, okay? And so now we're going to talk about some shortcuts that you can use for when they ask you to add up a sequence or find the sum of a series that is infinite, that has those dots at the end of it, okay? And so to find the sum of a geometric or an arithmetic series, the first thing you have to do, obviously, is figure out, is it geometric or is it arithmetic? So remember, geometric is when you're multiplying by that constant number to go from one term to the next. And then arithmetic is when you are adding the constant number to go from one term to the next. So that is actually the first thing that you do, okay? After that, once you figure out it's geometric, to find the sum of it, to figure out what it would get, if it would diverge or if it would converge, then you actually have to find R, which remember, R is your common ratio. What number, which, you know, when you're figuring out if it's geometric, you actually would already know that number, but that's the first thing. And then you have to actually take the absolute value of it. So remember, absolute value just means that you make it positive, okay? So after you find the absolute value of it, there's one of two things that could happen depending on what that number is, okay? So the first thing would be if after you take the absolute value of R, if it ends up being less than 1, so in other words, like a number that is smaller than 1, then what that actually means about that series is if you start adding it up, it'll actually converge. Okay, so that's going to be one of those where when you start adding it up, it ends up actually getting really close to a number, or the sums start getting really close to a number, okay? And so remember, when it converges, you have to tell what it converges to. So to find that number, there is a little formula that you can use, okay? And so to find the sum, that's what the S means, remember, is sum. All you have to do, you have to find a couple things about the sequence, but all you have to do is take whatever the first term is of that sequence, and then you simply divide by 1 minus whatever your R was. Not after you take the absolute value of it, but whatever the R actually was, okay? So to find what that number is that it's going to get close to when you start adding it up, you take the first term divided by 1 minus your common ratio. And that'll just, you could just type it in your calculator and it'll give it to you, okay? Now, what's the other scenario? Okay, so remember, that's if the absolute value of the common ratio is less than 1. So then, well, think about what would be the opposite of that, okay? So the opposite of that would be if the absolute value of that number was actually greater than or equal to 1, okay? If that's the case, so in other words, if it's any number that's bigger than 1 or equal to 1, then all you have to write down is that that sequence, when you start adding it up, actually diverges, okay? Because that's actually going to be kind of like that first sequence that we looked at in the other video. That's just going to keep getting bigger and bigger. So you would write down that it diverges. And with diverges, that already means that it's just going to keep getting bigger and bigger and bigger. And so you don't have to put anything other than it just diverges, all right? If it converges, that's where you have to put the extra stuff. That's where you have to do this formula, okay? And so this is when it's geometric. So remember, this is for if it's a geometric series, okay? So now let's talk about, well, what do we do if it was arithmetic? These are actually your easier ones. So when it's arithmetic, you can, yay, this is going to be a super easy one, okay? And the reason for that is because if you end up either adding or subtracting a constant number to go from one term to the next, that means it's arithmetic. And all arithmetic series or sequences, when you start adding them up, they will actually always diverge, okay? So if the sequence is arithmetic, then it diverges. diverges, okay? Every single arithmetic sequence will diverge. So then your answer will just be, it diverges, okay? Which remember, diverges means that it's just going to keep getting bigger and bigger and bigger because it does not have a finite limit, okay? So let's practice this with a couple problems so you can see how it works. And then we'll hopefully see how you feel when we meet, or you can email me, okay? So the first thing you do, remember, is you figure out, is it geometric or arithmetic, okay? So if it's multiplying the same number each time, then it's geometric. If it's adding the same number each time, then it's arithmetic. So what am I doing to go from 24 to negative 12? Negative 12 to 6. Well, to go, if it kind of looks like it might be geometric, because if you look at the signs, they're alternating. And so the only thing that sometimes does that is when you're multiplying by negative. So I'm going to see if it's geometric first, okay? So what would I multiply 24 by to get negative 12? What would I take negative 12 by and multiply it by to get 6? So 24, if I take that and I multiply it by 1/2, in other words, divide it by 2, because that's the same thing, then it would give me a positive 12, but what if I end up multiplying it by negative 1/2? Well, then that would give me a negative 12. And then I could check it. If I take negative 12 times negative 1/2, would that give me 6? And it would. And if I take 6 times negative 1/2, would I get negative 3? And so, yes. And so that means that it is geometric. So that's the first step. And now I have to find the common ratio and take the absolute value of it, okay? So my common ratio was negative 1/2. And now I'm going to take the absolute value of it. So the absolute value of negative 1/2 is, just make it positive, 1/2. And then I'm going to look, which category is this in? Is it less than 1, or is it greater than or equal to 1? 1/2 is a number that's less than 1. So what that tells me is that this sequence, if I started adding up the terms, it would actually converge. And so all I have to do now is figure out what it's going to converge to. So I just have to plug my information into this formula. So I'm just going to go to the side and I'm going to find, okay, what is my first term? Well, when I look at it, my first term is right there, 24. So it would be 24 divided by 1 minus my common ratio. So it'd be 1 minus, and then my common ratio before I took the absolute value of it was negative 1/2. So then from there, I just have to simplify. So it'd be 24, and again, you could just type this in your calculator if you wanted to. But it would be 24 divided by, well, 2 negatives make a positive. 1 plus 3, or excuse me, 1 plus 1/2 ends up being 3/2. And so, again, you can either type this in your calculator or you can try to figure it out by hand. Just remember, if you're dividing by a fraction, you have to flip and multiply. But then either way, you end up getting 16. So what that means is if I started adding up this sequence and I extended it like in the other video and I kept adding it up, the numbers would end up getting really close to 16 without actually getting to 16. So you would say it converges to 16. Okay? So then the next problem, same kind of thing. I'm going to figure out what's going on here. Okay? So if I take and I try to find the pattern here, am I multiplying by a number? Am I adding a number over and over? And it kind of looks to me, just by looking at it, it kind of looks like I'm multiplying by a number. So I'm going to go that route and see if it works. And if it doesn't, I'll backtrack. So I'm going to think, okay, what do I multiply 1 by to get 1/3? Well, I'd have to multiply it by 1/3 to make that happen. So I'm going to see, is that the pattern? Is it geometric? Okay. So 1/3 times that, I would get 1/9. If I take 1/9 times the 1/3, I would get 1/27. So that means that is my pattern. So since I am multiplying by 1/3, that means this one's also geometric. Okay. So then from there, that means my common ratio is 1/3. I'm going to do the same kind of thing. All right. So have to take the absolute value of it. So if I take the absolute value of 1/3, remember it just makes it positive. So that would make it 1/3, it doesn't change it. And then I'm going to look at that number. Is it less than 1 or greater than or equal to 1? And this one's also less than 1. So that means that this one also converges, okay? So I will have to erase this. Let me grab my eraser here. Okay, so I'm going to erase this so I can do the next part. So then this means that it converges, and then I have to find that number that it converges to. What number does it get close to? So I use that same formula. So it'd be S equals my first term, which is 1, over 1 minus my common ratio was 1/3. And then you can just type this in your calculator, or you can do it by hand. But either way, I think this one comes out to be 3/2. So the number that this is going to get close to, without actually getting there, would be 3/2 or 1.5. Okay, so then the next one, well, same kind of thing. I'm going to see what kind of sequence is it. And this one's a little harder because these fractions are a little bit different. So you can grab your calculator. Don't forget you have that. And you can just start seeing. So like if I wanted to see if it's geometric, in other words, I'm multiplying by the same number, you would take 2/3, take one of its terms, and divide it by the one right before it. So if I take 2/3 divided by 1/2, and again, you can always do this by hand, I end up getting 4/3. So if it's geometric, that means that I'm multiplying by 4/3. So I'm going to take 2/3, and I'm going to multiply that times the 4/3, and I'm going to see if I get 5/6 out of it, because if it actually is geometric. And so when I do that, I took 2/3 times that. I actually ended up getting 8/9. So that means that that is not geometric because I'm not multiplying by the same number. So now we got to see, is it arithmetic? Okay, well, to see if it's arithmetic, that means I'm adding a constant number. So to figure out what that number is, because again, fractions are not fun to deal with in that case, you take one of its terms and you actually subtract the one before it. So I'm going to take 2/3. And I'm going to subtract the one right before it, which is 1/2. And I'm going to see what I get here. And I get 1/6. So I'm going to check that out. Am I adding a constant number? So I'm going to take 2/3. And I'm going to add that 1/6 to it. And that gives me 5/6. So that means that this is actually an arithmetic series. So when it's arithmetic and they ask me to find the sum of it, my answer, remember, these are the ones that you can get all excited about because it's really easy. Every single arithmetic series, that you get, when they ask you to add it up, will actually diverge. So that is your answer. Once you figure out that it's arithmetic, then that means that if you started adding up that sequence, it would do what's called diverge, which, remember, means that when you start adding it up, it will get bigger and bigger and bigger without having a limit to it. So that would actually be your answer, okay? So if you guys need more examples or anything else, because we didn't get to do one of these, so like if you find a geometric series where after you take the absolute value and it ends up being a number bigger than 1 or equal to 1, then remember, it's kind of like this one. You just write down that it diverges, okay? So if you need to see an example there, just ask. I really don't mind doing it. I'm just trying to keep the videos a little shorter. So have a good day.